Kia ora Year 9. This is the first video that I'm making in 2020 for you, and it's an extension task looking at how we convert fractions to recurring decimals. So I want you to make sure that you've got your maths book and pen ready to go, because when I do these videos, I don't just want you watching, I want you doing maths as we go along. So you should be watching this video if you're already confident with our basic fractions operations. So I'm talking about addition, subtraction, multiplication, and division, and you also are going to need to be confident with how to switch between mixed numbers like 4 1/3 and improper numbers. So if you're good with those skills, then go right ahead and start watching. We're going to do some easy examples first, and then it's going to get a little bit harder, and at the end there'll be a Dr. Frost worksheet to go with what I've done in this video. So let's start off by looking at how we convert fractions to non-recurring decimals. Now some of these are going to look really stupidly easy, because most people look at 1/2 and they know what it is as a decimal. It's 0.5. We're going to look at how we can get there. So in this case, this number means that 5/10 is the same as 1/2. So we're using our basic ideas of equivalent fractions. So that's 1/2, right? What about 3/4? Well, 3/4 is a little bit trickier, because if I multiply 4 by something to get 10, I'd have to be multiplying by 2.5. If I do that to 3, I get 2.5 lots of 3, which is 7.5 out of 10. So I need to change that again, and I get 75 out of 100. So 3/4 is equal to 0.75. Now, both of those are non-recurring decimals, right? They stop, that's the end. 1/2 is equal to exactly 5/10 and nothing extra. I'm going to show you now a way that probably your parents and your grandparents learnt to figure out how to go from any fraction to any decimal, and it's called short division. So have a look. Try not to find it too weird, but you might want to ask at home about it. So if we've got 1/2, we can write that as 1 divided by 2. And we have this weird notation that most of you won't have seen that is a division sign. So let's do one that's not a fraction of that first and see how it goes. Well, suppose we want to know 312 divided by 3. So this is a very long detour towards recurring decimals, but we'll get there. So we say, well, we've got 312 and we want to divide it by 3. So we look at the 3 and we say, this 3 here means 300. How many times does this 3 go into 3? Well, it goes once. So we write the 1 up there. Now we look at this 1 here, which means 110. And we say, how many times does 3 go into 1? Well, it doesn't go in any times. So we write down a 0. But we've got this leftover 10. So we hop it up here and we say, well, now we've got a 10 plus 2 1. So we've got 12. How many times does 3 go into 12? It goes in 4 times. And that's how we used to learn division before we had calculators. So let's do another one like that. 684 divided by 2. Now you learn at school with numeracy strategies how to do that really easily in your head. So this is just an example for the sake of it. We write it like this. How many times does 2 go into 684? Well, let's look at the 2 and the 600. 2 watts make 6. 2 3s make 6. 2 watts make 8. 2 4s make 8. 2 watts make 4. 2 2s. So my answer's 342. One more. 712 divided by 4. How many times does 4 go into 7? Once. But we've got 3 left over, so we write the 3 down here. Now we treat this as 31, because it means 31 tenths. How many times does 4 go into 31? Well, it goes in 7 times, and we have 3 left over. Now we say, how many times does 4 go into 32? It goes in 8 times. So that's what we call short division, and that's what we're going to be using to work with recurring decimals. Now, let's go back to our funny example of how we figure out that 1/2 is equal to 0.5. Right, we've already seen that that's 5/10. Let's look at how we can do short division to get the same answer. So we're saying how many times does 2 go into 1? Well, we know that 2 goes into 1 0 times, but we've got 10/10 left over. So we can put down an infinite stream of zeros down here, and that's how we're going to think about it. So how many times does 2 go into 1? It goes in no times, but we've got 1 left over. So now we're working here with 10. How many times does 2 go into 10? It goes in 5 times. And we're done. We've got nothing left, so we didn't need all those. Let's try 3/4. How many times does 4 go into 3? Well, we could start by putting these zeros down. 4 goes into 3 no whole times. But we've got 3 whole numbers left over. So we carry that over. It's like when you do standard written form with multiplication. So 4 goes into 30 7 times. 4 sevens are 28. We've got 2 left over. How many times does 4 go into 20? 5. And now we've got none left over, so we're finished. So 3/4 is equal to 0.75. So we're going to apply that idea now in exactly that way to work out how to go from fractions to recurring decimals. Now recurring decimals are pretty cool. If you look at 1/3, we're thinking about what will get me to 100. When you're younger, you might think, and you're really smart, you might think, if I times by 33.3, I'll get 100. But you won't. You'll get 99.9. So we're not quite right. So it's not 33.3 over 100. So let's see what we can do. Well, we can use the idea we had here. We've got 1/3 is equal to 1 divided by 3. How many times does 3 go into 1? Well, it goes in 0 whole times. So we've got 1 left over. How many times does 3 go into 10? It goes in 3 times. 3 3s are 9, but we've got 1 left over. Ah, we've got the same thing again. How many times does 3 go into 10? 3 times. Look what's happening. Every time we've got 1 left over. So that's never going to stop. It goes on forever. So we've found our first example of a recurring decimal. 1/3 is equal to 0.3333 ... We want a nice, elegant way to write that. So we write it like this, 0.3, and often we'll see a dot on top of it, or sometimes we'll see a line on top of it. Kind of depends on what textbook or what country you're looking at. So that's our first recurring decimal. So let's do one more, and then you're going to have some to do. So let's look at 1/7. This one is a bit cooler and more interesting than 1/3. So 1/7 means 1 divided by 7. So we're going to set up the division. This is one that I want you to get down into your books as a good example. How many times does 7 go into 1? Well, 7 can't fit into 1, so it goes in no times. And we've got this 1 left over. So when we carry that 1 over, we tend not to think about what it means too much, but it means 10/10. Okay, so how many times does 7 go into 10? 7 ones are 7. So that's going to be 1 there. So if you need to jot some things down, 7 ones are 7. So there's 3 left over from 10. So we carry that 3. Now, how many times does 7 go into 30? 7 fours are 28. And we've got 2 left over. So now 7 watts will go into 20. 7 twos will go into 20. 7 twos are 14. And we've got 6 left over. So each time we're carrying here, 7 times watt will go into 60. 7 eights are 56. And I've got 4 left over. Watt will go into 40. 7 watts will go into 47 fives. And now I've got 5 left over. 7 sevens are 49. I've got 1 left over. 7 watts. Oops. 7 times watt is 10. 1. Now, hang on. I'm back at the start, right? Because I'm back to having 10. And so now I'm going to have 3 left over. 7 watts go into 34. So you can see that the pattern's starting to click around again. So we've got 0.142857, and now we're going to have the same thing again, 142857, and it's never going to stop. So 1/7 is equal to this, 0.142857, 142857, and so on forever. But because we've got that repeating pattern, it's a recurring decimal. So we can write it like this. Okay, so we put 2 dots, 1 dot at the start of the pattern and 1 at the end. So that's 1/7. So there are an infinite number of digits when we write it as a decimal, but there's a pattern in the digits. Okay, and so that's the first one. So I want you to try a couple before you go off and do some Dr. Frost. I want you to work out 4/7. And what's the other one I wanted you to do? So that's a bit the same as what we've just done. I'm just looking at all my bits of paper. Yeah, 4/7 and do 5/7, just to give you some practice at that short division idea. Okay, so here's 4/7. 7 doesn't go into 4, so we carry over the 4. 7 watts into 40. 7 5s, 5 left over. 7 7s give me 49. I've got 1 left over. 7 1s here. I've got 3 left over. 4 here. 2 left over. 2 here. 6 left over. 8. 4 left over. 5. And then you can see I'm back to having 5 left over. So I've got 7. So you can see the pattern started to repeat here. So 4/7 is equal to this, 0.571428, with the dots over that and that. 5/7 is very similar, right? So how many times does 7 go into 5? It goes no times. I've got 5 left over. 1 with 3 left over. 4 with 2 left over. 2, 6 left over. 8, 4 left over. 5, 5 left over. 7, 1 left over, and we're back at the start. So 5/7 is equal to 0.714285. Now, I haven't got much time left in this video, and you're doing well if you've watched the whole way through. Just make sure that you've got some good examples of how to do that down in your book, because I'm going to do another video where I do some harder ones. So far, the 5 and the 7 have both just had 2 digits, but we'd like to be able to do things like this. What's 7/12, right? Or what's 19/27? And we need a different division method for this, which is called long division. So I'm going to teach that in the next video. Okay, so all you have to do for this video is make sure you've got some nice clear examples down in your notes, and then watch part 2 of this. Thanks for watching.